Okay guys, so in this video we'll be taking a look at the Edexcel Maths Core 1 topic questions from papers, and it's the inequalities section. So welcome to this next section where we're looking at inequalities for Edexcel Core 1 Maths. So this is aimed at Year 12 students and Year 13 students. So AS Pure Maths and A2 Pure Maths. And it's also appropriate for Gcse further maths students and also Gcse higher tier as well. Okay, as ever guys, please feel free to pause the video, try and attempt any questions or all the questions you can do first, and then come back, press play and check your answers. But if you're not comfortable doing that, then please do grab your notepad or some paper, take some notes on your pen and paper. Okay, put the title as Inequalities, and it's looking at Core 1 Maths. So it's an old specification, but it's still appropriate for this current new specification that we're doing now, okay, in 2022. Okay, this is question number 6 here from the June 05 past paper. Part A, find the set of values of x for which 3 lots of 2x plus 1 is greater than 5 minus 2x. Well, expanding the bracket, so 3 lots of 2x is 6x. And 3 lots of 1 is going to be 3, so 3 lots of positive 1 is going to be plus 3. That's strictly greater than 5 minus 2x. Okay, adding 2x to both sides to balance the inequality, 6x plus 2x is going to be 8x, so 8x plus 3 is strictly greater than 5. Okay, taking away 3 on both sides of my inequality to balance it respectively, I get 8x is strictly greater than 2. And then dividing both sides by 8, we get that x is strictly greater than 2/8 or 1/4 or 0.25. Okay, either answer is appropriate. Okay, as long as the sign is in the correct way. So x is strictly greater than 1/4. Okay, so x can take any value that is bigger than 1/4 or 0.25. So x could equal 1, x could equal 2, x could equal 3, x could equal 4, okay, etc, etc. X can't equal 0 or -1 or 1/10, okay, as an example. Okay, part B, solve this quadratic inequality. So I've got to factorize this. Okay, so to make 2x squared, I'm going to put a 2x and an x. Okay, so 2x goes here and an x goes here. Okay, I've got a minus here and a plus here. Okay, so two numbers that add to give me -7 and multiplied to give me +3. Bear in mind that one number is going to be doubled. Okay, so if I put a 3 here and a 1 here, I get 2x squared minus 6x minus 1x, which gives me -7x, and then -1 times -3 is +3. Now, I'm going to sketch the quadratic curve. Okay, so my solutions would be 1/2 and 3. So it's going to look like something like this, okay, as a rough sketch, okay. So my solution is 1/2 there, or 0.5 and 3. Okay, remember that where it crosses on the x-axis, that's when you set y equal to 0. Okay, so you'd set this equal to 0 and you'd find your two solutions. So either 2x minus 1 equals 0 or x minus 3 is 0. They will tell you your two solutions at which they cross on the x-axis. Okay, it crosses the y-axis at 3. Okay, if you're interested, at +3. Okay, because of this +3 here. Okay, when x equals 0, y is 3. Okay, so we want it above the x-axis. So we want it above y equals 0. So it's going to be everything on this side of the curve and everything on this side of the curve. So that means the set of values that it can take, okay, it will be x is strictly less than 1/2. okay, and or x is greater than 3. Okay, they will be your two sets of inequalities that satisfy that quadratic. Okay, it's when, so the question that we're being asked to solve is, when is the graph above the x-axis? It's above the x-axis for all the parts that I've shaded in red. Okay, it's above the x-axis there. Okay, so it goes on essentially for infinite amount of times. Okay, it's not above it here. Okay, it's below the x-axis here. So here would be when it's less than 0, and then it's above the x-axis when it's greater than 0. Okay, at this point and at this point. Okay, so they are your two solutions to the quadratic inequality. X is strictly less than a half, or x is bigger than 3. Part C, it says find the set of values for which both the linear inequality and the quadratic inequality, okay, match. Now, obviously, it says x is bigger than a quarter, okay, so it could take the value, okay, so got to be very, very, very careful here. So it could take the value of a quarter here and a half here. Okay, because it's less than a half, but then greater than a quarter. Okay, but it could also take the value, okay, so it could also take the value of x is bigger than 3, because when x is bigger than 3, that will satisfy this inequality, because any value that is bigger than 3, okay, will be true here. Okay, and in fact here, I could even put an equal sign because, okay, if I was to have x equals 3, then that would satisfy this, and it would also satisfy this. But I think because of the greater than sign here, I can't put that equal sign. So I may be mistaken here. So please let me know in the comments here whether or not I need to put an equal sign there or not. I'm under the assumption that we're basing it off the information that we're given, okay? So they would be your two sets of solutions, okay? X can be between a half and a quarter, okay, because it's less than a half and bigger than a quarter, but it could also satisfy x is bigger than 3, okay? So that would be treated as two separate inequalities, okay, for that one, okay, for that to be true, okay? So for that one. Question number 2, find the set of values of x for which this quadratic inequality is above 0, x squared minus 7x minus 18 is greater than 0. Well, we would obviously factorize the quadratic, so put it into double brackets, okay. This one's a bit easier, okay, so x and x make x squared. I want two numbers that add to give me minus 7 and times to make minus 18. Well, it'd be minus 9 and positive 2. Or positive 2 and minus 9. Okay, so then sketching our quadratic, it crosses at minus 2 and 9. Okay, and it goes through minus 18 on the y-axis. Okay. So it's going to look something like that. Obviously, I haven't drawn it perfectly, but hopefully you can forgive me. Okay, so that's the value of 9, and that's the value of minus 2. Okay, so we want it for when the graph is greater than 0, so it's going to be when x is strictly less than 2, or when x is bigger than 9. Okay, the question's asking us, when is the curve, okay, when is the quadratic curve above the x-axis? Okay, it's above the x-axis at x is less than minus 2, or x is greater than 9. Okay, so it should be a 2 there, guys. It looks like a 1. Oops. Okay, so your solutions to the quadratic is when you set both of these equations equal to 0. Remember that where it crosses on the x-axis, that's the solution to the quadratic equation. Okay, it crosses the y-axis at -18. Obviously, I haven't drawn it to scale, but hopefully you can forgive me for that, okay, because obviously doing it freehand is a bit more tricky, okay? But make sure that even with a sketch, guys, don't take your pencil, okay, off the point until you've gone from this part of the curve until the end part, okay, for that. Question number 4, guys, part A, find the set of values of x for which this inequality, okay, is solved. Okay, so I'm going to add x to both sides of my inequality to balance it. Okay, 4x plus x is going to be 5x. So 5x, take away 3 is strictly greater than 7. I'm now going to add 3 to both sides of my inequality to balance it. Okay, plus 3 plus 3. I'm going to get 5x is strictly greater than 10. And then dividing both sides by 5, we're going to get that x is strictly greater than 2, guys. Okay, dividing both sides of my inequality by 5. Okay, because 5x means 5 times x for that question. Okay, part B, solve this quadratic inequality again. So we've got to factorize this quadratic, okay, into a double bracket. Okay, apologies about my handwriting, guys. Hopefully you can forgive me. Okay, so this time is when the graph is less than 0. So it's when it's below the x-axis. Okay, we factorize this into 2x and x. Two numbers that add to give me -5 and multiply to give me -12. Remember that one of them is going to be doubled. Okay, if I put a -4 in here and a +3, okay, I've done this obviously by trial and error. Okay, 2x times -4 is -8, plus 3x gives me -5x, and then +3 times -4 is -12. So two numbers that add to give me -5x and multiply to give me -12, and similarly here, two numbers that add to give me -7 and multiply to give me -18. Okay, they were -9 and 2, or 2 and -9. Okay, this one obviously I've got a coefficient in front of the x squared, so it makes it a bit more trickier. Okay, but you look at your factors of 12 and just do like test cases. Okay, again, sketching this quadratic, it crosses at -1.5 and 4. Okay, so roughly, and it goes through -12 on the y-axis. Okay, sorry guys, apologies about that. Let's just try that again. Okay, a freehand is always a bit tricky, guys. Okay, it's obviously not perfect, but hopefully you can forgive me. Okay, so when is the graph? So that's going to be -3/2. Okay, there, and then that's going to be 4. Okay, because that's my solutions to the quadratic equation. Okay, you'd set this equal to 0 and you'd solve each linear equation separately. I get -3/2 and 4. When is the graph below the x-axis? Well, it's below it here. Okay, so it's below it between -3/2 and 4. So your solutions for part B would be that -3/2 is less than x, and then less than 4. Okay, for that one. Okay, so that would be your solution to the quadratic inequality. Okay, now part C says we're going to find the overlap between this linear inequality and this quadratic inequality. Okay, so when we solve this, we get x bigger than 2. So it goes from 2 to 4, guys. Okay, so 2 is less than x, and then less than 4. Okay, because it goes from 2 to 4. Okay, so that's my answer for part C. And thereby, I think I've made a mistake on the previous part C of the previous question. So do forgive me on that, okay? So I'll put the correct solution to part C of question 6, okay, in the description below and in the live chat, okay? But hopefully you can forgive me, okay, because I put down 2 sets of solutions. But when we're looking at both here, we're looking at the overlap between the linear inequality and the quadratic. Okay, obviously x has to be bigger than 2 and less than 4, but it can't go back to minus 1.5. So this is my answer to part C. I'll put it in square brackets just to be very careful and clear. Okay, that's the overlap between the linear inequality and the quadratic inequality. Okay. Right guys, that's the end of today's short, sharp video looking at inequalities, solving linear inequalities and quadratic inequalities. I sincerely hope you found it useful. I hope you found it informative. If you did, please hit that like button. Please hit that subscribe button if you're new to the channel. And lastly, please turn on post notification by clicking the bell icon next to the big red button that says subscribe. Okay, and please feel free to share my videos with anyone that is doing their A-level maths this year or next year, or even resitting their A-level maths this academic year. Okay, please feel free to share my videos for any students doing AS Pure Maths, A2 Pure Maths, and even A-level further maths as well. Okay, but that's it for me today, guys. Thank you so much for watching. My name is Abdallah Wahishi and I run Abdallah Maths Tutor 2022 channel. Okay, I also offer private tuition, so please check that out if you're interested, for all levels ranging from Key Stage 1 right the way through to A-level further maths. Okay, so let me know if you're interested in having an online tutor or a face-to-face tutor. Okay, but that's it from me today, guys. Thanks for watching. I'll see you for the next one. Okay, bye for now.